Well, thank you. Hold on a second. Let me set it in. Okay, here we are. And second here.
Water okay?
Yeah, totally cool. Thank you so much.
Okay.
All right, here we are.
For you?
Thank you. Yeah.
There you go.
All right. Got it. Appreciate it. All right.
If
Thank
you
you.
need anything, just shout.
Thank you. All right. Thanks, Ian, for the introduction as well. So again, my name is Suphannee, and welcome to my talk. And for this session, we are going to talk about Google reCAPTCHA, one of the most internet frustrated, security control, right? So I think you know this box. You hate it. I'm pretty sure it's very frustrated when you Exactly. Yeah. It's never been frustrated to prove that you are human these days. And it's, for years, it's work, right? And then we give everybody AI. Now, full disclosure here, I am one of the person who broke reCAPTCHA before back in 2016 when I was a PhD at Columbia student. Back there, we are actually the first researcher group that using AI back there, 10 years ago, using deep learning. It's called CNN, if you're familiar with vision model. The model is actually a paid model, so we paid money for it. But with that, we're able to get accuracy around 70%. And, we presented it at EuroSNP, also like Black Hat. Now, 10 years passed, right? And a lot of things have changed. Google have come up with a new reCAPTCHA version. They introduced a lot of challenges that's actually much more harder. So in this talk, we're gonna try to break Google reCAPTCHA, but we're gonna do it with zero cost, and we try to run it in the your local machine using open source local models. So that's mean zero API requests. And I want to also mention that this is my personal work, nothing related to the work that I do at my current employee, by the way. So they told me to state that. Anyway, why does this matter, right? As you know, reCAPTCHA is really big service. There are 5.6 million company using reCAPTCHA today, and it's a gorilla in the internet. You see it everywhere. It's ranked at #1. It's almost 100% market share. So CAPTCHA is usually is sitting between attacker and automate attack, right? Think about credential stuffing, or you want to do you want to fake register something, you want to buy a ticket, or you want to complete your attack chain, right? CAPTCHA is usually popping up so that stopping a bot from complete the whole attack chain. So now with the power of AI these days, right? It's actually even more important because now the bot go to the internet, scraping the contents, the data, trying to complete the work for someone, for example. Now, one thing is that the assumption that seeing for a bot is hard. This is completely untrue anymore. This is completely dead. I would say now bot is actually better than human. So yeah, and here we are. And in fact, right, many work in the past, including my work in 2016, it has proven that reCAPTCHA or in general visual CAPTCHA is already very solvable, right? You can see the work from 2016. There's work from recent one from 2025, presented in Usenik Security. They were using GPU 4.0. Again, it's a paid service here. They're able to achieve the accuracy around 60%. So it's definitely solvable, but there's always a catch because people always use paid service in order to do this. But again, in this talk, in the Summercon talk, we're gonna do it with 2 local model, open source. So that means it's completely free, right? And it's actually, I'll mention it later, but you can do it even with zero code. And we're able to get the successful rate around 90%, 92%. So, all right. Before that, here is how reCAPTCHA works. So first, you get to click the checkbox. I am not a robot. Then once you click it, what happened in the background is Google trying to score you. Google trying to see your cookies, Google trying to see your browsing history, where's your network, is this trustable network, are you in Tor or something, right? And they come up with score, and you're gonna get score. And then if you get in the higher score, meaning that they trust you, they think that, okay, this is really a human, you get a checkbox right away. You don't have to answer any CAPTCHA, you just pass. Right? Now, if you get into a lower trust, Google didn't trust you, you might be a bot, you get to solve image CAPTCHA, right? That is how it works today. And the image CAPTCHA is like treated as fallback. So the irony part is, if we can have a bot that can solve image CAPTCHA for you, you want the fallback to happen. Right? You don't need to spend time building, your browsing history. I did that before in 2016, getting the cookie, building browser history. It takes time. But with, if you can solve the CAPTCHA, image CAPTCHA effectively, then this is exactly what you wanted to happen. So very ironic. All right, in order to do this, we split the work into 2 phases. So the phase 1, we call it offline. So the offline here, we'll use like Selenium WebDriver to go to visit of multiple live website. We'll download to collect Google CAPTCHA, including images, instruction. We want to study them in this case, and after we get it to our local machine, we try to label them, right? We try to answer those CAPTCHA, but not for training. It's just for, for us to understand what model works best for us. We want to test it offline first, and we want to get the accuracy, seeing what model, seeing what threshold to be used. Then we'll take whatever we know, we'll take the best model that we have, and then we'll do it online. So the online one will, again, use Selenium to go to a real website that have reCAPTCHA deploy, either to be before you logging in, before you register, and try to use those to if we're able to really pass the CAPTCHA or not. And yeah, that's how it worked. So, all right, for offline, then we try, again, like I said, we try to understand them. So this is what we've seen. So reCAPTCHA have 2 types. Right? It's called type A and type B. This is how we call it. Type A is combining with 9 images, which I'll show later. And type B is just 1 image, which, again, I'll get to you on that. So let's take a look at type A here. So type A is actually, you're going to get an instruction to select an object. And you get a 9 images. They are completely different. And it's you have to choose that object. Now, there are 2 subvariants for type A. So the first variant is called static, meaning that you just select the one that match the object that you have to select, and you just get 1 pass. So the other one is called dynamic here, and the reason why it's called dynamic is because when you select the tile got refreshed. Even if it's got refreshed by itself. So you have to keep selecting until you don't see that object anymore. So you get to pass that CAPTCHA. And this is definitely going to take longer, right? Because it got refreshed and so forth. But technically, both subvariant, they are object recognition from AI perspective. Now, type B, again, they are not the same. Type B, you just get 1 single image. They slide it into 16 small images here. And your task is to select the square that contain that object. Okay. So in this, type of B, CAPTCHA, is, if you know, it's called spatial detection, which is another type of, image detection here. All right, so now we know that there's 2 types of CAPTCHA. So what we do is that we want to get the best model that works best for us, right? We have used something called clips, and the other one called all v2. So both model, I want to state again that they are 0 cost. They are open source. You can go and download it from Hugging Face, and there's no GPU required. If you have GPU, that's great, even better. And there's no training. You can use it like pre-can, everything. And There's no API. So it's completely free, and you can run it on your local laptop. All right, the first model here, Clips. Clip is one of the most well-known visual model, right? And what usually Clip give you is that you can give Clip model with two things. You can give image and a keyword. So the keyword here could be the object that you need to select, right? So what Clip does is that it's trying to map the image and the text in the vector space. And if they are closer together, you get something called, they're gonna return you something called cosine similarity, which is a score that, the higher it gets, it's gonna tell you the closer of those two are. So, it's mean that that keyword is likely to be that image. Okay, so which is great for task A, right? Because now we can then take every tiles, every images that we have, and then try to calculate the cosine similarity score, right? We try to ask, does this really look like fire hydrant or something else? So what we did is that we'll come up with a score that we calculate the cosine similarity of fire hydrant and the images minus the cosine similarity of the images and the something else, right? Once we get this score, we'll test it with each, if they pass some threshold that we found that, oh, this is effective, then we select that tiles, right? For example, if you over 0.01, we'll select that. If you lower, then we're not selecting it. We also experiment with different size of model. Clips also train. The researcher that provide Clips has trained them with different parameters. Starting from 86 million to 632 million parameters, and we see that the one that worked the best, we're able to achieve the accuracy around 58%, which is, you might think that, oh, this is really low. Actually, it's like flipping a coin, right? Flipping a coin is like 50%. This is a little over that. But one thing is that a bot can always retry, right? And that changed everything. And we'll come back later about this point. Just keep that in mind for a sec. All right, the next model that we want to solve for type 2 is called all v2. All v2 is that, this model gonna give you two things. So one is the bounding box, which is the area that cover that object, and the confidence value, which is how confident it is that that object is in there. So right. So how do we select a tile in this case, right? So there's two-step process here. So the first one will first we'll take the confidence score. And if it's below some threshold, we're not gonna select it because the model not sure that is that really the object in there. Now, if they pass that threshold, we go to the step number 2, which is calculate the coverage. So, for example, right, in the tile number 3 here, you can see that the bounding box, it just cover a left corner, left bottom corner section here, around 10%. So it's lower than some percentage. We're not going to select it. We only select the one that have a higher coverage, right? For example, in this case, we'll select tile number 2, tile number 6, and tile number 7, for example. All right, with this two-step method, we're able to achieve the accuracy around 43%. We tested it on the offline data set that we have. And we also retested with the clip model that I presented before with each of the tiles, but clips actually perform worse. It's just 12%. So here is the reason why we need different model for different type of capture in this case. All right, now you might be wondering why so far I have said that we only have accuracy around 50 to 60%, right? But like I said, the bot can always keep trying. So that's mean you can always spawn 5 browsers at the same time. If one of them win, then that's it. You already passed the captcha, right? And if you really like to do math here, you can then do the probability that I have put it here. Now, if you can try just one, if you success 1 in 5, then you end up about from 58%, it's going to be jumped to 98% already. So, but yeah, the key is bot can always try, right? Retry. All right, how to make the bot look like human? So now we know everything, right? Like we know what's the model that best for us. We want to go live. We want to see if our attack really work. So what we do is build, again, we'll use Selenium to do this, like I mentioned before. But we also need to make sure that Google didn't detect us as the bot as well, right? We hide some of the things that, not like, we don't want them to know that we use WebDriver to do this. So we hide like, Navigator, web browser, WebDriver, sorry. We also like move the mouse, like, wrote a program to like move the mouse a little bit slower, getting some delay, a little bit offset here so that, to trick the Google to like, oh, this is like a human, right? And on top of that, because we want the reCAPTCHA to happen, and it's like, we want the scenario that it's close to attacker as much as possible. So we use like a browser with no history at all, no Google sign-in, completely fresh every time, right? So every time we every time we do this, there's no history involved at all. All right. Now in a live session, one thing that I want to mention that in a live session, Google, you not really get one single challenge. In one session of Google reCAPTCHA, you get multiple challenges, and it could be alternating between type B, type A. You get the number of challenges, and the thing is like if Google think that you are suspicious, you get more challenges. Like you can get like 10, you can get 5, for example. It depends. And so in our live session, when we're testing it, so we will take, we'll test on 500 session, and we're able to, and you can see from the CDF graph that we have. So you can see here that our session is usually finished around like, 10 seconds here, up until like 6 to 7 minutes, usually the blue line here. And the number of challenge that we got is roughly, starting from even just one challenge up to, 20, right? And you might think, oh, why 20? Because we actually set the maximum to 20. I mean, you can keep going, honestly, but we set the maximum to 20 and declare that, okay, this is done. We're not going to continue it anymore, and, moved on. And we declare that it's a fail. So with this, live session that we test, we are able to get successful rate at 92%, 92.6%. On the median, the average, the time that we use is around 1 minute, and we'll get around 3 challenges per session. So yeah, I think it's quite successful. So now you think that why live session is actually better than offline. So the thing is like when we do the offline experiment, we'll, because when we label it, we use the human to label, right? And when we grade them, we like, the model have to select exact, the model have to select exact tiles. The model have to select, if there's 3 boxes need to add, three tiles that you need to click, the model need to click 3 tiles. That is how we grade in the offline. Now in the live session, right? Number one is that like Google actually grade you more loosely. They don't want you to be so much frustrated, right? I mean, it's already frustrated when you answer the CAPTCHA, and if you have to be really precise, then I don't think you failed CAPTCHA before. I'm pretty sure. And just to give you an example here, right? For example, in this CAPTCHA, you have to select motorcycle. The question is, do you select just only the motorcycle part or the rider as well, or the human part? It's kind of like depends on person to person, right? So that's why Google grade you more loosely, and the facts that as I stated before, right? In one session of Google reCAPTCHA, in a live one, you get multiple challenges. So that means you get to be retiled by yourself, like Google give you a retile. So that's great for the bot too. So that's why our accuracy in real world is actually higher. Now, all right. So far, like I mentioned, right? Okay, this is great. We get 90% accuracy. That's awesome. So I want to mention one thing. Everything that I have been said so far, I done with zero coding. So I have been wipe coding all the time. I didn't do any single line of code. Like I just tell them to like, oh, do this, do that, and the agentic AI powerful just come up with everything by its own. It's just, suggesting model that I should be using, which is great. So, and that is great, right? Because now you can, if you are a Claude user, for example, you can have like something called skill. I'm not sure you're familiar with it, but this is something that you can describe in English. So you can break CAPTCHA with just a simple instruction in English now. You don't have to you don't have to know how to use Selenium. You don't need to know how to do Python code anymore, right? And we did that. We tested it because the model is the agentic model is so great. You don't even need to understand Clips or all model, right? They use like multi-model that already have it in agentic AI these days. So with that, we're able to we tested it with 50 challenges offline. Now you might ask like why 50 challenges? I ran out of tokens, by the way. It's a lot of token to spend here. I need sponsor. It's personal work. Anyway, so with that thing, you end up like 98%, right? And you spend all of token, then you get into the point of token withdrawn. I'm not sure if you have that, but I do have it. But yeah. So anyway, so you can use English to break Google reCAPTCHA now. You don't need to be a researcher. All right. So, but one thing I want to mention is that zero code is not it's still limited by physics here, right? So even if you use prompt only, just use agentic AI to help you, usually it takes more time. It usually takes 30 to 60 seconds for each of the challenges. The reason is that you need to send these images back to the cloud, right? And then the model is gonna do the thing, depend on your subscription, depend on how much token, depend on the load. It usually takes longer to complete the work. And when you get something like harder, a lot of the tile that got refreshed, then it even worse because you have to do it more time. So that being said, if you use the prompt only, you might end up getting queued by 2-minute timeout. So that, but in this case, you get more accuracy, yes, but you might end up queued by timeout. But if you use our local model, it's always free, and you can retry whenever you like. It's completely free, running on your local machine, pretty fast, right? In any case, you can pick which one to use. Attacker always win this day now. All right, key takeaway here. So number one, the bot always win. So I already said it. They're actually even better than probably all of us trying to do the CAPTCHA. So number two is the skill floor is now dropped to 0. Back there when I was a PhD, right? 10 years ago, 2016, it take the whole research lab to do this work. Now it's just me with Claude, less than a week of work, and we'll get this thing right away. So anybody can be a hacker. Number three is the fallback paradox. So like I said, right? Whenever Google or the service don't trust you, they prompt you with something that you have to do, some challenges, okay? Which is kind of now is benefit attacker, it's benefit the bot too, right? Because we want, the bot is actually better than human, so we kept counting on it to happen. So yeah, no need to build browsing history, no need to build your cookies, whatever, reputation, you don't need that anymore. So the safety net is the trapdoor, right? So think about it if you see something like reCAPTCHA or something similar service like that, it's gonna be speed bump now. It's not a war anymore. It's just slowing down. So yeah, and we should treat them as maybe the end of life from now on. All right, I think 10 years ago I have break this, and but now we can do it just wipe coding free model on a laptop, and yeah, and oops, I did again. So anyway, but yeah, so the data is available in the link, and also there's a demo video that if you're interested to see how it works. I don't think we have time for it, but yeah, thank you so much, and I'm happy to take any questions.
Hello.
Hello.
Thank you so much for the presentation. It was very interesting. My question is, CAPTCHA really feels very useless. And what do you think the future of this is going to be? Do you think they're going to
Sorry, can you
remove it?
say louder? Sorry, it's a little bit noisy.
Yeah, I said that CAPTCHA really feels very useless. And what do you think is going to be the future of that? And if it's going to be removed, it's going to be changed because it's been there for a while.
Yeah. Actually, great question, right? Like, I mean, a lot, like, I think, for example, Google reCAPTCHA V3, they're trying to move away from, using any kind of like visual captcha at all. Like, they're trying to like score you, reputations and stuff. I think that is a great move for sure. But again, the fallback that, like I said, right, the fallback is actually the one that we attacker counting on. So I think it's still unclear whether direction that where should we going with this, especially with an AI developing like a rocket every day. So I would say we'll see. I don't know. Like reputation is one of them that I see, but again, there's always a way to break this. It's always a cat and mouse game. So.
Thank you. On slide 20, you were showing a motorbike with like a yellow box in the corner where I suppose the model...
Is that right?
19 then, maybe? Yeah.
Okay.
Box 14 is where the model detects the motorbike, but there is no motorbike. Can that kind of mistake be used as a tell in the cat and mouse game that you referred to?
Can you repeat the question? Sorry, I didn't get that. Like.
So is 14 looks like it's a wrong detection?
Yeah, totally.
Have you seen any of that kind of tell being used for bot detection?
You mean like, if we have a lot of like false positive selection or something? Oh yeah, for sure.
Like
Yeah, totally. I mean, great question, by the way. So when we experiment with this, right, especially in live session, like I also recording like how many we get, right? And if you review the logs, you can tell like if you miss a lot, you get more capture right away. Like, I mean, they try to, okay, now you miss like 5 in a row, you get 5 more in a row. So like, as like a punishment. Exactly. They're trying to like delay you. I would say like, delay you or delay the bot even further. Yes, of course, I can see that. But like I said, right, I mean, something like maybe if we miss just like one, like human does this all the time. But to your point, yes, they do that. All right. Cool. All right, and well, thank you everyone again. If you have any questions, feel free to like contact me. So.